Alright guys, I'm introducing the Boson Subnet Calculator. This is a subnetting calculator you can use when we get into the IP addressing portion of the Cisco 1 course. And I kind of want to demonstrate how to use it because this is what we'll be using in class. Now it's just another resource to help you learn subnetting. So I've put in a host IP address of 192.168.10.15. It's a Class C address. It's identified by the subnet calculator. And here it means I have, with this address, using classful addressing, I only have one subnet, and I have 254 hosts on that subnet. Now, I've not described and explained to you how to come up with these numbers, but I'm just showing you, without going into too much detail, how this works. So the current network that this IP address resides is in the 192.168.10.0 network. Remember, the network address is similar to what we think of as the zip code. It just needs the neighborhood. It doesn't need the individual address. When we look at a host address now, that has to be unique, and that's handled by the router that's closest to the connected network. And ARP will play a role in figuring out the IP address that resolves to the MAC address on that subnet. So it's letting me know that my current range on this network is usable IP addressing is 192.168.10.1 all the way into 192.168.10.254. This is the range of IP addresses I can use for hosts. The 255 network is saved for the broadcast, and it tells you down here this is for the broadcast. Now notice that the last octet is set to all ones. That's how you know it's the broadcast. When the host portion of this network IP address of all ones, it's the broadcast address. So that's a little tip to remember. But what if I want to change this? What if I want to actually do subnetting? Now subnetting means I'm going to borrow bits from the host. And depending on the class, you know, how many host bits I have, that's how many I can borrow, right? I can't borrow what I don't have. So the last octet in a Class C is set for hosts, and that's 8 bits, but I can't use all of them. I can only borrow up to 6 bits. We have to leave 2 bits for hosts, otherwise we'll just have subnets with no hosts. So only up to 6 bits can I borrow. If I do that, let's say I borrow 1, I change things. Alright, if I borrowed 1, it changed the entire thing. So next thing I know is I have a subnet mask that's different. Instead of 255.255.255.0, I now take a bit from the host bit and move it over to the network portion. It means the subnet mask has to reflect that, so the computer knows what portion is networked. So now I'm .128. And I haven't really shown you how we arrive at the chart that we use so that we can calculate these subnets and subnet masks correctly. But I do have a chart from a workbook that we use, and I'm going to show that to you shortly in another video. I do kind of want to make this a little bit shorter, so just notice that with 1 bit borrowed, I created 2 subnets, and I have 126 hosts per subnet, right? So I have fewer hosts, and the host bits now that are remaining are 7 instead of 8. So taking that 1 bit created something new, and it allowed me to create 2 subnets. I don't have to purchase an additional IP address from an ISP provider. I can take what I've been given and subnet it. Alright, so theoretically that's how it should work, but we use NAT behind our private networks, and we only use very few public IP addresses. So that saves us money. What I do want to show you is how it breaks it all down into binary. And we're going to learn ANDing. ANDing is Boolean logic, and this is how the computer actually derives at the network address. It takes everything in binary and ANDs out the address. ANDing is very important. When you can't figure out an IP network, when you have an IP address, maybe it's a Class A, and you really can't see what network it belongs to, break it down into binary and AND it out. So here's the logic for ANDing. A 1 and 1 is true. Everything else is false. So if it's true, we mark it. So 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0, 1 and 0 is 0. Only 1 and 1 is true. And everything that's marked is true means we'll mark it, and that's what we'll add up for decimal. And that's how you AND out a subnet when you don't have a calculator and you really have to figure out the subnet. Now, this will all make more sense as we start going into the Chapter 11 for IP addressing. I also have an IPv6 subnet calculator that will be very useful as well. I do want to mention that the broadcast address has also changed. There's a difference here. Later on, as I show you subnetting, the long version of subnetting, not the subnet calculator, this is actually a shortcut. You'll appreciate the subnet calculator a lot more. All right, the subnet calculator application is in MC Canvas, and you can download it and put it on your computer.